Hello everyone. So we are going to discuss today two-port network. Two-port network is second last class. I think today is the okay. So in yesterday class, what we have done? In yesterday class, we have discussed transformer and mutual inductance. Second, mutual inductance. And third is revision. So today we will discuss. Today we have transformer. One important topic is left, so I will do one transformer topic. And second we have transformer, and second we have question discussion. Okay. So this is the formula section which I have discussed in yesterday class also. So I have attached this formula section in this PDF only. So you can go through this formula section and you can write it down. You can just write it down and you can just remember that thing. It is very easy to calculate everything. So you have to remember the everything, or you have to derive everything. So this is conversion from one parameter to another parameter. This is also conversion for H parameter. This is also conversion for ABCD parameter, and this is also have a reciprocal and symmetrical network condition, and we have the T network and pi network condition, and this one is lattice network, and this one is for series network, shunt network, series shunt network, or shunt series network, shunt series. This one is series shunt, and then after we have a series parallel, transformer, and mutual inductance representation. Then after we have a series parallel condition and cascade condition. So we have discussed lot of more things here. So then after we will go through the next topic, next point, that is transformer section. In transformer section we are going to discuss some R equivalent question, because R equivalent question they will ask in the exam, and it is very important for maximum power transfer theorem. So I will tell you the R equivalent question related to this. So how to find R equivalent, C equivalent, everything like this. Yes sir. So this is our transformer. Yes sir. We have N1, and here turn N2, and here one impedance is attached. So here something like that R is attached. Then they are asking what is R equivalent. What is R equivalent? So we have to find out R equivalent. Here current is I1, here current is I2. So I can say that in transformer net power loss should be 0. So power here, and in this case no power amplification. So in transformer power consumption in first port and second port are same. So power consumption in first port and in first port, power consumption in first port and second port, in port 1 and 2 are same. So we can write it down. We can write it down R equivalent formula. So I1 square into R equivalent is equal to I2 square into R. So we have I equivalent is equal to I2 square upon I1 square into R. Yes sir. Or you can write it down no power loss. You can write it down also like this. There is no power loss in the transformer. There is no power loss in the transformer. Okay. So we have I2 upon I1 is equal to N1 upon N2. So R equivalent is equal to N1 upon N2 whole square into R. So this is two-port network point. First point is this one. So R equivalent is equal to N1 by N2 whole square into R. If impedance is given, so Z equivalent is equal to N1 by N2 whole square into Z. If inductance is given, so N1 upon N2 whole square is equal to L. L equivalent is equal to. And if reactance is given, so X equivalent is equal to N1 by N2 whole square into X. You can write it down like this. Then if we have admittance is given, so in case of admittance the ratio will change. In case of admittance the ratio will change. So Y equivalent will be equal to N1 by N2 by N1, N2 by N1 whole square into Y. If susceptance is given, so N2 by N1 whole square into Y. If capacitance is given, what capacitance is given, so N2 by N1 whole square into C. And if conductance is given, so N2 by N1 whole square into G. So we can go through this point and we should remember this all three points. So then there is a chance that the port will interchanged. That means they will ask in right hand side, in the first port the resistance is connected, and they will ask in second port. This type of question may be asked. So there is a chance for opposite direction also question, opposite type of question. So we have question like this. So they will ask question like this also. So here we have I1, here we have I2, here we have R, and here R equivalent is asked. They are asking R equivalent. So, and here we have N1 and N2. Yes, sir. So first of all, I1 square into R is equal to I2 square into R equivalent. Yes, sir. So R equivalent is equal to I1 upon I2, that means N2 upon N1, N2 upon N1 whole square into R. So this is for resistance. So for impedance, reactance and inductance, admittance, conductance, capacitance and susceptance. So we have N2 upon N1 whole square. Yes sir. And in this case the ratio will be same. In this case the ratio will be same. But in case of Y, the ratio will interchanged. The ratio will interchanged. This is G equivalent, this is C equivalent, and this is B equivalent. Yes sir. So into Z, into X, into L, into Y, into G, into C and into B. So this is the point here, you can remember. So these are the all points regarding two-port network. We have studied everything about two-port network. Then one question, then we will go for question discussion. This is first question. So they are asking Z parameter. As we have studied, Z parameter is equal to Z11 is equal to ZA plus ZB, Z12 and Z21 is equal to ZB, and Z22 is equal to ZB plus ZC. Yes sir. So this is ZA, this is ZB and this is ZC. So we have ZA is equal to 1 ohm, ZA plus ZB 3 ohm, and ZB 2 ohm, and ZB plus ZC 5 ohm. So we have Z parameter. So Z matrix will be 3, 2, 2 and 5. You can go through the Y matrix also. Y matrix is Z inverse. Yes sir. So Z inverse 5 3s are 15 minus 4 11, 1 by 11, and 3 5 it will be replaced, and this one is minus 2 minus 2. So Y parameter will be 5 by 11 minus 2 by 11 and minus 2 by 11 and 3 by 11. So this is our Y parameter. So they will ask X parameter, they will ask Z parameter, or they will ask Y parameter. They will ask H parameter also. So for H parameter we have to derive the notation. So we will go through the more and more question like this. This is the question for Z parameter they are asking. So for Z parameter what we will do, first of all inductance will be replaced by LS, LS means S, and capacitance will be replaced by 1 by CS, 1 by 2S, and inductance will be replaced by LS, 3S. And now you can find out the value. This is ZA, this is ZB, and this is ZC. So you can find out Z parameter. So Z parameter will be ZA plus ZB, ZA plus ZB. So ZA plus ZB S plus 1 by 2S and 1 by ZB, 1 by ZB and 1 by ZB, ZB plus ZC. So 3S plus 2 by S, 1 by 2S. Yes. Okay. So this is our Z parameter. It is very easy to calculate. So Z11 is equal to ZA plus ZB, Z12 and Z21 is equal to ZB, and Z22 is equal to ZB plus ZC. So you can go through the formula and you can calculate this question. Then we have next point, Z parameter of this network. So there is a two method by which we can calculate Z parameter. First we will calculate Y parameter, then we will calculate Z parameter. Or second method is, first we will find out T network, then we will calculate Z parameter. So there is a first chance, so that first method I will try. What I will try? YA, YB and YC. YA is equal to 1 by 3 ohm. This is the error which the student do. YB is equal to 1 by 3 ohm and YC is equal to 1 by 3 ohm. Then we will calculate Y parameter. Y11 is equal to YA plus YB. So it is 2 by 3. And Y21 and Y12 is equal to minus YB. So it is minus 1 by 3. And Y22 is equal to YB plus YC. So it is 2 by 3. So our Y parameter will be 2 by 3, yes sir, minus 1 by 3, minus 1 by 3 and 2 by 3, yes sir. So 4 by 9 minus 1 by 9, 8 by 4 by 9, 3 by 9, 1 by 3 it will be. So Z will be equal to Y inverse. So Y inverse it will be equal to, for this 1 by 3, determinant of Y is 1 by 3, and second thing is we will interchange this position. So 2 by 3 and 2 by 3, and this minus will be plus 1 by 3 and 1 by 3. So this 3 and this 3 will be cancelled out. So our Z parameter will be 2, 1, 1, 2. So this is our answer for Z parameter. Y, and this is, so very easy. Inverse you know how to calculate, so it is very easy to calculate. Second method is, you can go through the T network concept. So this pi network is converted into T network first of all. Second method is, you can go through the T network concept. So this is our T network. First one is ZA, ZB and ZC. So for ZA, what it will be? ZA is equal to and ZB is equal to, ZC is equal to, it will be 3 into 3 divided by 3 plus 3 plus 3. So it will be 1 ohm. So our T network will be 1 ohm, 1 ohm, 1 ohm, 1 ohm, 1 ohm, 1 ohm. This is our T network. Yes. So we have ZA is equal to 1 ohm, ZB is equal to 1 ohm and ZC is equal to 1 ohm. Then we have Z11, ZA plus ZB. So it is 2 ohm, and Z12 and Z21 is equal to ZB, which is equal to 1 ohm, and Z22 is equal to ZB plus ZC, so which is equal to 1 plus 1, 2 ohm. So our Z network will be, Z parameter will be 2, 1, 1, 2 ohm. So this is a very easy concept. You can go through that. Okay. Then we have if you don't know the parameter matrix conversion, I will tell you, because it will be used very fast, more and more times. So this is R1, R2, R3, and this is RA, RB, RC. Yes. So how I remember? So for R1, what is the formula? For R2, what is the formula? And for R3, what is the formula? Okay. Here summation of R is summation of R I will use. That means RA plus RB plus RC. RA plus RB plus RC. So what we have to, RB RC in place of R1, RB RC are nearer. So RB RC divided by summation of R. In place of R2, RA RB is there. So RA RB and divided by summation of R. In place of RC, for R3, RB RC is near. So RB RC divided by summation of R. So this is the point here. Next point is how to calculate RA RB RC. So summation of R, R1 R2 is what? R1 R2, R1 R3 and R2 R3. This is the meaning of this one. Then RA is equal to, RB is equal to, and RC is equal to. RA is equal to summation of R1 R2. This one is also summation of R1 R2, and this one is also summation of R1 R2. And in place of R1, opposite side is RB. So I will divide. Sorry, for RA is where? Here this one is RA. This one is RA. Yes. Okay. So RA RC, first one. For R2, RA RB. For R3, RB RC. Yes. Okay. So in play for R1, R3 is opposite, divided by R3. For RB, R1 is opposite, divided by R1. And for RC, R2 is opposite, divided by R2. So you can go through the formula like this. So what we have decided? For R1, RA RC, R2, RA RB, R3, RB RC, divided by summation of R, summation of R, summation of R. For RA RB, RA is divided by R, RA opposite R3 divided by R3, RB opposite R1 divided by R1, RC opposite R2 divided by R2. So this is the formula for this one. In case of for L, the formula will be same. For C, I will replace C 1 by C, 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 1 by C. So for capacitance, what I will do? R will be replaced by C. So here we can note that, that for L the formula will be same. For L the formula will be same. For L Z X the formula will be same. And for capacitance, what it will be? For capacitance, what it will be? So for capacitance, the nature will be changed. So for capacitance, so this one is Ca, this one is Ca, this is Ca, Ca, Cb and Cc, and next is Ca, Cb, Cc, R1, R2, R3. Next is R1, R2, R3, C1, C2 and C3. So R will be replaced by 1 by C. So R is replaced by 1 by C. Remember, R is replaced by 1 by C. So C in place of C1, 1 by C1, 1 by Ca, 1 by Cc. And summation of R is, so summation of C is summation of 1 by C. 1 by C is equal to 1 by Ca, 1 by Cb and 1 by Cc. Yes sir. And for C1, 1 by C1 will be equal to, so I will write 1 by C1, and in place of C1 what we will write? We will write the formula C1 is equal to, so I will write C1 1 by Ca, 1 by Cb and 1 by Ca plus 1 by Cb plus 1 by Cc. So it will be, the value will be changed. So what will happen? C1 will be equal to CaCb, CaCc plus CbCa Cc divided by Cc, divided by Cc. Yes sir. So this is the point here. Yes sir. So like that you can remember, or you can remember like this also. So I will write C1 as a summation of CA CB divided by CC CB. Yes sir. And C2 will be equal to summation of CA CB and divided by CC, and C3 will be equal to summation of CA CB and divided by opposite is CCA. So like that you can remember. So this is the method you can remember the formula for C1, C2, C3. Summation of CA CB is equal to CA CB plus CA CC plus CB CC. Yes sir. Next we have second, how to find CA. So for CA, C1 C2, for CB C2 C3, like that. So for CA, C1 C2, so CA is equal to C1 C2 summation of C1, and CB C1 CB C2 C3 summation of C, and CC, for CC summation C1 C3 divided by summation of C1. Here summation of C1 is equal to C1 plus C2 plus C3. So first formula is delta to star transformation, and second formula is star to delta transformation, star to delta. So this is known as delta and this is known as star. So first one is delta to star, first formula, and second formula is star to delta. And in this case also you can remember that formula for Y, B and G, same formula we will use. Okay, like that here also. This formula is delta to star and this one is star to delta. Okay, next they are asking Z parameter. In this point they are asking Z parameter. I am fine grease. Then they are asking Z parameter. How to find Z parameter? It is very important. So Z parameter, you have to do one thing, that first of all this pi network should be converted into T network, and then you go for Z parameter. Or first of all you can solve by using equation method. That will be very tough. So what I will do, I will convert into pi's T network, this pi network into T network. This one is R1, this one is R2, this one is R3. Yes sir. So for R1, R2, R3, what it will be? So for R1, R2, R3, 6 into 6. Yes sir. And summation of R, 6 plus 6 plus 6. So it will be 2 ohm. Yes sir. So our network will be 1 ohm. And this one R1, 2 ohm. Second one R2, 2 ohm. And this one 2 ohm. And this one is also 2 ohm. So it is very easy to understand. Yes sir. So this one is R1, this one is R2, and this one is R3. Again we have this one is ZA, this one is ZB, and this one is ZV, Z1, ZA, ZB and ZC. So we have find out ZA, ZB, ZC. Now it is easy to find Z parameter. So ZA is equal to 2 plus 1, 3 ohm, ZB is equal to 2 ohm, and ZC is equal to 2 plus 2, 4 ohm. So 2 plus 1, 3 ohm, 2 ohm, and 2 plus 2, 4 ohm. Now we can calculate Z11. So Z11 will be equal to ZA plus ZB. So it will be 5 ohm. Z12 and Z21 will be equal to 2 ohm, ZB. So it will be 2 ohm. And Z22 is equal to ZB plus ZC. So it will be 2 plus 4, 6 ohm. Yes, sir. Then we have this Z parameter. Yes, sir. Now we know Z matrix. So our Z matrix will be 5, 2, 2 and 6. You can find out Y matrix also, Z inverse. So Z inverse, it will be 30 minus 4, 1 by 26, and it will be swapped 6, 5, minus 2, minus 2. So answer will be, Y parameter will be 6, 3 by 13, minus 2, 1 by 13, minus 2, minus 1 by 13, or minus 5 by 26. So this is our answer. This is our answer. Data structure, it is conducted na. So data DA, you know DA, data analysis. So for DA we have GATE exam. In that exam you can go through machine learning and artificial intelligence. So DA subject is added in GATE exam. You can go through that. Okay. DA. And many IIT is providing, many IITs, IIT Madras, I think, and IIT Kharagpur, Kanpur, and I know firstly IIT Madras is providing DA. For DA they are providing work from the distance learning program. For DA, data analysis, they are providing distance learning program IIT Madras. So you can go through that also. There are so many people who has joined DA. Okay. This is the question they have asked. Y parameter they have asked. So we have two methods to calculate Y parameter. First method is, you can go through that Z matrix, Z parameter. So you can go through the Z. Z11, 2 plus 2, ZA plus ZB, 4 ohm. Z12 and Z21 is equal to ZB. So it will be 4 ohm. ZB, it will be 2 ohm. And Z22 is equal to ZB plus ZC. It will be 4 ohm. Yes, sir. Then we have Z matrix. What is Z matrix? Z matrix is 4, 2, 2 and 4. You will ask, this type of question is asked in exam. Yes, so many times they will ask this question. Then Y matrix will be equal to Z inverse. Z inverse. So what is Z inverse? 4 4 are 16 minus 4, 1 by 12, and it will be 4 2 2 4. Yes sir. So it will be 4 by 1 by 3, 1 by 6, 1 by 6, and 4 by 6. So it will be minus 2 minus 2. So minus 1 by 6, minus 1 by 6, and 2 by 3, 1 by 3. Yes sir. So it will be 1 by 3. And its unit is per ohm, mho, or per ohm, or Simon. Okay. So this is the point here. So this is Y parameter which we have studied. So it is very easy. Second method is you can convert this into delta network. You can convert this into delta network, and then after you can solve. So delta network you can solve. So you can go through the delta network. So this is ZA, ZB, and ZC, or RA, RB, RC, R1, R2, R3. You can write, no problem with that. R1, R2, and R3. So for R1, it will be, so summation of R1, R2 is, summation of R1, R2 is, summation of R1, R2 is 2 into 2 plus 2 into 2 plus 2 into 2. So it will be 12 ohm. Yes sir. And we have R1. So R1 will be equal to summation of R, RA, RB कर दो. Okay. Okay. So R1 is equal to summation of RA, RB divided by RC. So it will be 12 divided by 2, 6 ohm. Similarly, R2 will be equal to, for R2, summation of R1, R2 and divided by RB. So it will be also 6 ohm. And for R3, summation of RA, RB and divided by opposite. So divided by RA, it will be 6 ohm. So our answer will be, so this is R1 6 ohm, R2 6 ohm, and R3 6 ohm. Okay. Then we have YA. YA is equal to 1 by R1, 1 by 6. YB is equal to YA, YB, YC is equal to, so YA, YB, YC is equal to 1 by 6 per ohm, and Y11 is equal to YA plus YB, 1 by 6 plus 1 by 6. Y12 and Y21 is equal to minus YB, and Y22 is equal to YA plus YB plus YC, YB plus YC. So this is 1 by 3 minus 1 by 6, and this is 1 by 3. Next we have Y parameter, which is equal to 1 by 3 minus 1 by 6 minus 1 by 6 and 1 by 3. So this is our Y parameter. Okay. So you can go through the, first of all calculate Z parameter, then Y parameter, or you can go through the delta network, then Y parameter. In this case they are asking Y parameter. So you can convert this into T network and then Y parameter, or Z parameter then Y parameter, or you can convert Y pi network and then calculate y parameter. So pi network is easy here. Pi network is easy here. How you calculate pi network? It is very easy. So this one is the pi network. So this is our pi network. So our network will be 6 ohm. This one 6 ohm, 6 ohm, 6 ohm. So this is the point here. Yes. Then after these two are parallel, so we can go through the parallel condition. So 3 ohm, they are in parallel, 3 ohm. Yes sir, they are in parallel 3 ohm. So these two are in parallel combination, so we have 3 ohm and we have 6 ohm and we have 3 ohm, and then we can go through the point. Yes sir. So what we have, this one is pi network. So pi network YA, YB, YC you can calculate. YA, YB, YC you can calculate. So what is YA, what is YB? YA is equal to 1 by 3. YB is equal to 1 by 6 and YC is equal to 1 by 3. So Y parameter Y11 is equal to YA plus YB 1 by 3 plus 1 by 6. Y21 and Y12 is equal to minus YB, so minus 1 by 6, and Y2 is equal to YB plus YC. So this is the point here. So we have Y parameters, that 1 by 6, so it will be 3 by 6 1 by 2 and minus 1 by 6, minus 1 by 6 and 1 by 2. Yes sir. Then I will go for Z parameter, so 1 by 4 and 1 by 36. So delta Y will be equal to 1 by 4 minus 1 by 36. So it will be 8 by 36. So it will be 2 and 9. Yes sir. 2 and 9. Then Z matrix will be Y inverse. So 9 by 2. And it will interchange 1 by 2. It will be plus 1 by 6, 1 by 6 and 1 by 2. So it will be 9 by 4, 9 by 4, 3 by 4, 3 by 4 and 9 by 4. So this is our Z parameter. So you can find out inverse, you will get the answer. It is very easy to calculate. Okay. Then we have one question, and thereafter again tomorrow we will discuss some more question also. So this is one question. Okay. This is Z parameter of the network. Yes sir. They are asking Z parameter. So for Z parameter you can make I2 is equal to 0. That means open circuit. And for Z parameter you can make I1 is equal to 0. But I2 is equal to 0 and I1 equal to 0 does not make any significance or does not make any large difference. So what we will do, we will go through that point that first of all I will go through the y parameter, because I will make V1 V2 0, then it will be very beneficiary. So V2 is equal to 0, short circuit, and V1 is equal to 0, short circuit. That will give you significant result. So we can go through the V1 voltage equal to 0, so that you can calculate very easily. So direct Z parameter calculation is very tough here. I will go through the direct y parameter calculation and then inverse z parameter calculation. So first of all I will go through the y parameter calculation. Why we have chosen y parameter calculation? Because in y parameter voltage is 0, V1 V2 is 0. So I will make V1 V2 is 0, and then after I will solve. Yes sir. So what I will do, first of case I will take V2 is equal to 0. If V2 is equal to 0, y11 is equal to I1 upon V1, and y21 is equal to I2 upon V1. Yes sir. So I will make V2 is equal to 0, this one as short circuit. Yes sir. This one as short circuit. Yes sir. If V2 is equal to 0, this one is open circuit. So this one is open circuit. V2 is equal to 0, this one is open circuit. Now it is very easy to calculate. This one is short, so this 1 ohm is not a good thing. So this I2 current will flow in this direction only. Yes sir. And we have I2 current will be this in this direction. Then we have I1 plus I2. Yes sir. Yes sir. Then we can go through the point. So here current is 0. Here current is 0. Then we have a chance. This current is flowing like this, plus minus. This current is flowing like this, so plus minus. There is no current, so no potential drop. What I will do, I will just apply KVL here. So we have V1 is equal to 6 I1 plus I2. 6 I1 plus I2. And then we will apply KVL in this direction. So in this case, what we have, minus 2 plus 6 I1 plus I2. Minus 2 plus 6 I1 plus I2. And minus 2 plus 2 I2. And plus 2 minus 2 V1. And then 0 is equal to 0. So this one is V1 is equal to V1 is equal to 6 I1 plus 8 I2, 3 I1 plus 4 I2, 3 I1 plus 4 I2. Yes sir. And V1 is equal to 6 I1 plus 6 I2. V1 is equal to 6 I1 plus 6 I2. Yes. So what we will do, I can do one thing. I will multiply this 2 times. So this is equation 1 and this is equation 2. So equation 1 is multiplied by 2 minus 2 will result 2 V1 minus V1 V1, and 6 2 V1 minus 6 0, 8 minus 6 2 I2. So it will be V1 by I2 is equal to 2 and ohm. So I2 by V1 is equal to 1 by 2. So V1 is equal to 2 I2. Yes. and V1 is equal to 6I1 plus 6I2, and V1 is equal to 3I1 plus 4I2. So here you can write 3I2. So anything you can use. You can use this. So V1 is equal to 6I1 plus plus I, in place of I2 I can write 3I2 3V2 V1. So V1 is equal to minus 3I1, or you can go through like this also. V1, yes sir, 3I1, yes sir, or plus 2V2 V1. So V1 will be equal to minus 3I1. So any method you can go. Any method you can go. So Y11 is equal to Y11 is equal to minus 1 by 3 I1 by V1, I1 by V1 minus 1 by 3, and Y21 is equal to I2 by V1. So it will be I2 by V1 1 by 2. Yes. Then second thing is, we have calculated this thing. Then what we will do? Then we will go for second thing. V1 is equal to 0. V1 is equal to 0. Yes sir. You will make V1 is equal to 0, and what will happen you can see. So V1 is equal to 0. Case 2, V1 is equal to 0. V1 is equal to 0, so we have Y12 I1 by V2 and Y22 I2 by V2. So we have V1 is equal to 0. This one is short circuit, and this one is short circuit. Yes sir. So we have I1, so here 0 current will flow. Then we have I1 plus 6V2 current. Then this current is flowing like this, so plus minus. Okay, and then we have current like this, I1 plus I2 and 6V2 plus minus. You can apply KVL here. So we have V2 is equal to I1 plus I2 plus 6V2, I1 plus I2 plus 6V2. So V2 is equal to minus I1 plus I2 divided by 5. We have equation 1. Then we will apply KVL here. In this case, what will happen? In this case, minus to plus I1 plus I2 plus 6V2, and this one is minus to plus I2 and plus 2 6V2, 2I2 and 6V2, 2I2 and 6V2. And here voltage drop is 0 because short circuit. So this one is equal to 0. So we have I1 plus 3I2 is equal to minus 12V2. So V2 is equal to minus times of I1 plus I2, 3I2 divided by 12. So we have V2 also. Yes sir. Then what we will do, then we have V2 is equal to minus times of I1 plus I2, minus times of I1 plus I2 divided by 5, and V2 is equal to minus times of I1 plus I2, I1 plus 3I2 divided by 12. Then we can relate I1 plus I2 divided by 5 and I1 plus 3I2 divided by 12. They are same. So we have 12I1, 12I2 and 5I1 and 15I2. Yes sir. So we have 12I1, so 12 minus 5, 7I1 and 15 minus 12, 3I1. 2. Yes sir. I will put in terms of I1, so V2 will be equal to minus, for I1 I will put 3I2 upon 7 and plus I2 divided by 5. So it will be 7, 10 minus 10 I2 and 10 divided by 5, 2. So 2 I2 upon 7. So Y22 will be equal to I2 upon V2. So it will be minus 7 by 2. Minus 7 by 2. Then Y12 will be equal to V2 upon I1 upon V2. I1 upon V2. I1 is 3 by 7 I2. 3 I2 by 7 divided by V2. I2 by V2 is minus 3 by 7 and I2 by V2 is minus 7 by 2. So minus 3 by 2. So we have Y matrix. What we have Y matrix? Y matrix is 1 by minus 1 by 3 and 1 by 2. Minus 1 by 3 and 1 by 2. So this is a very big question. So minus 1 by 3 and 1 by 2. And second point is minus 7 by 2 minus 3 by 2. Minus 7 by 2 and minus 3 by 2. This is our Y matrix. Then Z parameter will be delta Y will be 1 by 3 into 3 by 2 minus plus 7 by 2 into 1 by 2. So 1 by 2 plus 7 by 4. So 9 by 4. Then we have Z is equal to Y inverse. So 4 by 9 and Z inverse it will interchange minus 3 by 2 minus 1 by 2, and this one is 7 by 2 and 1 by 2 minus 1 by 2. Just you can multiply, you will get the answer. 2 will be cancelled out, so 2. So it will be 2 and minus 3, so minus 2 by 3, and this one is 2, so 2 will be cancelled out to 2, 4, 17, 7 2s are 14 by 9, and in this case 2 will be cancelled out, minus 1 by 2 by 9, and in this case 2 will be cancelled out, so it will be minus 1 by 18, 2 by 18. By 9. Yes. So this is our Z matrix. This is our Z matrix. So you can see here, this is our Z matrix. Once again I will also check, because sometimes I will do errors. 6I1 plus I2, yes. Then we have 6I1 plus I2, 2I2 and 2V1, yes, minus 2V1. So 2V1 is equal to 6 3I2 and 6 to 8 4I2. Okay, then we can equate. So if we can equate, so we can get what we will get, 3I1 and 3I1 and minus 2I2, or you can go through that also. So 2V1 minus V1 V1, 6 minus 6 0, 8 minus 6 2, yes. So V1 by I2 is 2, I2 by V1 is 1 by 2. Okay, 2I2 and we can go through this also. So we have 4I2, 2I2, so 2V1, V1 is equal to minus 3I1, yes. So V1 by I1 is equal to, I1 by V1 is equal to minus 1 by 3, and I2 by V2 is equal to 1 by 2, yes. Then we have this equation. I think this one is also I have solved correctly. Then we have calculated Y parameter, then we have calculated Z parameter. Okay, so we have completed the two-port network as of now. Then after tomorrow, Monday, we will go to discuss some more questions. You can solve by yourself also. This is the question which we have solved right now. So we have solved this question. Then after we have to calculate Y parameter for this one, and H parameter for this network, and H parameter for this network, and ABCD matrix for this network, and ABCD matrix for this network, and ABCD matrix for this network, and we have some more question related to that. So we have the questions, we can go do this question. Okay, so up to this we will do the question. So we will meet it again. 1 minute, I will come back. 1 minute. So we have completed. So what we have completed? Some transformer related problem, and second we have calculated question discussion. So question discussion and transformer related problem. Okay, you can join the group Sonu Sir PW. This is my Telegram group, so that you can connect with me. Thank you everyone.